Guys, so this is the only time I'm ever going to do this. I'm actually going to do some of the homework with you because it's all review of Algebra 2, and it goes over concepts you're going to see a lot. And so I'm going to go over the even ones with you, then you can try the odd and check the answers in the back. So this is from problem set 1. For me, this is page 12. And so I'm going to go over several of the even problems with you. So number 4, okay, I'm reading from our Trig book. 20% of the molybdenum fuse, like I don't know what that is, but it's probably from chemistry. If 1420 grams did not fuse, what was the total mass that was used? So they're telling me that 1,420 did not fuse, and that must represent 80%, right? Because they told me 20% fused, so that means 80% did not. So I'm setting this up in that way. So 1420 represents 80%, which would be 0.80. And I put of the total. So I put of molly, I'm going to call it molybdenum, okay? Then I solved, right? So I'm going to divide by 0.8. So I know the amount not used would be 1,775 grams because it asked how many was used. So if this represents 80%, then M must be the total. So this is the total, I got myself all confused, of grams that were part of the problem. Okay, so that's number 4. Number 6 is complete review of exponents. So I'm just going to go over how I did it. So 2 to the negative third, x to the 0, x squared, x to the negative third, xy negative 3, y. Okay, so remember, anything that's negative, I'm going to move. Okay, and anything that has an exponent of 0 equals 1. Hopefully you remember that. And if you don't, I'm telling you in the video. So x to the 0 just equals 1, just a side note. Okay, so I'm going to simplify this. I'm going to move x to the third on top. X to the 0 becomes 1 times x squared. I'm moving 2 to the third on bottom. And I'm going to move this guy to the top as well. So then I've got times x times y, and up here went y to the third. So I'm going to simplify that. Over here I'm going to write anything to the 0th power equals 1. Okay, so that's what that is. So now I'm going to simplify here. I've got x to the 5th, y to the 3rd. And on the bottom, I got 8xy. So if we simplify that, I'm left, there's a 1 here and a 1 here. I'm going to subtract exponents. So my answer is x to the 4th, y squared over 8. So that is what you should get there, simplifying it in steps. Okay? All right. Next, I'm going to go over number 8. Oh boy. 8 in your trig lesson wants us to simplify xy over y to the negative second minus 3x4 y4 over x cubed y plus 7xy negative second over xy negative 3. Okay, we are going to simplify each fraction first. Okay? Don't try solving number 8 until you simplify each one. So this one becomes x y to the 3rd, right? Because I'm moving x to the negative second to the top, and then the exponent becomes positive. Okay, so then minus, now I'm going to simplify him. I get 3x y to the 3rd, right? I'm simplifying. I'm subtracting exponents. 4 take away 3 is 1. 4 minus 1 is 3. Okay. Then I'm going to simplify this last one. The x's cancel, and I'm going to switch the y's, leaving me with y, right? Because this would move to the top, this would move to the bottom, so I'd have y to the third over y squared, and I would end up with 7y. Now, from here, if it was possible, I would combine some like terms, and in this case, I actually do have one. These two here are like terms, so this equals negative 2xy cubed plus 7y. Crazy problem. Notice Trig jumps right in with some tougher Algebra 2 problems. Right, moving on to number 10. Notice too, my work is readable. I'm boxing the answers so you can see them clearly. This would be a great example of then, if you scan this to me, it'd be really easy to point out the work. All right, number 10. I don't think you need me to review this, but I am just in case. Negative x minus 5 equals negative 3x to the 0 minus 2. So remember, anything to the 0th power becomes a 1. Okay, so then this just leaves me with 2x minus 5 minus x minus 5 equals negative 3 times negative 2. Whoops. Equals 1 minus 2, which is negative 1. Okay, 1 minus 2 is negative 1. I'm going to combine like terms. So this is x minus 10 equals 3, which would mean x equals 13. So pretty simple. Once you start simplifying and anything to the 0th power goes away, then it's just simply combining like terms. All right, number 12. Number 12 is a rational example. It's from later on in the year when I think we were actually already close to being digital at that point. Okay, so I believe this is all they wrote for number 12. We have to find a least common denominator, which in this case is x times x plus 1. So I'm going to multiply this one by x and this one by x plus 1. So I end up with 2x plus 2 plus x squared over x times x plus 1. Okay. All right, I distributed 2 times x, 2 times 1 plus x times x. So that's where I got 2x plus 2 plus x squared over my common denominator. From here, I'm going to simplify. I get x squared plus 2x plus 2 over x times x plus 1. Now, if I could, I would factor the top and simplify, but the top is actually unfactorable. So I cannot factor the top part. So I'm going to leave it. So there's number 12. Now, oh boy, guys, number 14. I cannot tell you how many problems in this book you will do involving systems. That's why there were so many sections on it in Algebra 2. So I'm going to set up number 14 with you. Okay, and I am going to notate it quite a bit differently than them because I think they make it super complicated. Notice number 14, they already wrote the system for you, but I'm just going to write N for nickels and D for dimes. And then 5n plus 10d equals 450. So, some review. If you don't remember how to solve a system using elimination, I'm going to make these equations opposite. I got to make opposite coefficients. So, I'm going to multiply this top equation by negative 5. And that gives me negative 5n minus 5d equals negative 250. Then I'm going to add these, and that gives me 5d equals 200, which means that the number of dimes equals 40, 40 plus N has to equal 50, so I know nickels equals 10. Pretty simple if they set it up for you. If they didn't set it up for you, it's not as simple. For example, number 16, they told me that I'm going to use N for nickels, D for dimes. They told me that the number of nickels exceeds the number of dimes by 7. So the number of nickels exceeds the number of dimes by 7. So that would mean that nickels equals dimes plus 7, right? Whatever the dimes, so if dimes were 10, then I would have 17 nickels. So set it up so that it makes sense if you were to plug in actual numbers. Then they told me the value of the coins is $1.55. So I know that a nickel is 5 cents, right? So 0.05 times the number of nickels plus 10 cents per dime equals $1.55. So notice I kept all the money together. Now in number 14, we used elimination because it made the most sense. Elimination makes the most sense when you've got your variables on the same side, simple opposites. In number 16, the method that makes the most sense would be substitution. So I'm actually going to substitute the value of N into here. And maybe you guys already remember this, but if you don't, that is why I'm going over it for this very first section, and that's it. So 0.05 times D plus 7 plus 0.10 D equals $1.55. He would then distribute, so I get 0.05 D plus 0.35 plus 0.10 D equals $1.55. So that would give me 0.15 times D equals $1.20. Divide and dimes equals 8, so that means nickels. If I know that if dimes is 8 plus 7 means that the number of nickels is 15. All right, now I had you skip 18, so that is not in here. And the rest of the homework is from lesson number 1. And so that's all I'm going to go over today. The rest of your homework is review from the lesson I taught. This stuff I covered today was review specifically from last year. So hopefully that helped. If not, then hopefully my notes helped.